Hey guys, today we're going to use a few different factoring techniques to simplify rational expressions. Alright, here it is. Okay, so to simplify rational expressions, you need command of your factoring skills, as well as some exponent rules. And so, just like normally when we factor, the first thing you want to look for is a greatest common factor. And so, when you do these, you want to treat them, the numerator and denominator, separately at the start. And so we're just going to look at the numerator here, and we're going to see if we could find a greatest common factor to factor out. So between the 10x squared and the 90x, I can factor out a 10x. And so I'm going to rewrite my fraction bar, and I'm going to factor out a 10x out of my numerator here. And so if I do that, 10x times x will give me my 10x squared. And 10x times 9 will give me my 90x. Okay. And then the denominator turns out to be fully factored here, so I'm just going to recopy that. And then now that we have a fully factored numerator and a fully factored denominator, we can look for things to cancel. And so I know that my 5x will go into my 10x twice. And so I can rewrite this as 2 times the quantity x plus 9. Okay, another way you can think about this is 5 goes into 10 twice, so I have a 2 in the numerator, and the x's cancel, so x divided by x is just 1. And then I'm left with my x plus 9 in the numerator, and then there's nothing, all of the 5x was canceled, so there's just 1 left in the denominator, and so we don't have to write that. So this is the fully simplified form of the original expression. Okay? And now similarly, we will look for, again, we're going to treat the numerator and denominator separately. And the numerator is fully factored, so I'm just going to go ahead and rewrite that. And now I'm going to look for a GCF, a greatest common factor, to factor out of the denominator. And it looks like that's going to be 18x squared. Okay, and 18x squared times x will give me my 18x to the third. And then 18x squared times negative 2 will give me my negative 36x squared. Okay. Now again, we can divide things out here. So I'm going to rewrite my fraction bar. And I know 9 divided by 18 is 1/2, so I'm going to have a 1 in the numerator, but I'm not going to write that because I'm going to have other things in the numerator, so 1 times anything is just the other thing, so there's no need to write that. So, but I have this 1 in the numerator, and I'm going to have a 2 in the denominator, again, because 9 divided by 18 is 1/2. And then I have 2 factors of x here that are going to cancel with 2 of the factors of x up here, but since there's 3 factors of x in the numerator, I'm going to have an x left over in the numerator. Okay, and another way you can think of this is your exponent rule for dividing powers with like bases, right? X to the third divided by x to the second is x to the first, and so that's why I have an x to the first in the numerator here. And then I have this factor that didn't get canceled with anything left in the denominator. Okay, and so there's your fully factored expression. Okay, Now for these, again, it's always nice to look for a GCF first, but there is no greatest common factor between these three terms in the numerator. And so I can't factor out a GCF, but what I can do is I can factor this trinomial into a product of binomials. Okay, and again, I'm ignoring the denominator for now. I'm just looking at the numerator. And so I'm going to assume you have some familiarity with factoring trinomials here. So I'm going to move through this a little bit quickly. So I know I need an x times an x to give me my x squared. And now I know I need one of each sign because I need this number times this number to equal a negative number, and the only way to do that is if I have one of each sign. And then I need the factors of 21 that will combine to a positive 4, so that's going to end up being a positive 7 and a negative 3. Okay, and now this here, again, no GCF to factor out, but it's a difference of squares, so I can factor that. Again, I have a video on factoring differences of squares if you need to get a reminder, but this is just going to be x plus 3 times x minus 3. Okay, and now we can look for factors to cancel. So I see I have a factor of x minus 3 in the numerator, and I see I also have a factor of x minus 3 in the denominator, and so they will cancel because anything divided by itself is just 1. And what I'm left with is x plus 7 all over x plus 3. Okay, now for this one here, I have a trinomial in the numerator, trinomial in the denominator, no greatest common factors to factor out, but I can trinomial factor these. Okay, I'll do the numerator first. I need either both signs to be negative or both signs to be positive since I'm multiplying to a positive number, but since I'm combining to a negative, I know they both need to be negative. And now I need the factors of 24 that will combine to a negative 11, and that's going to be negative 8 and negative 3. Same signs, and the factors of 18 that will combine to a negative 9, that's going to be negative 6 and negative 3. And again, now I have a factor of x minus 3 in both the numerator and denominator that will divide to 1, so that cancels. And that's what I'm left with. Okay. And then I have one last one here that is a bit more difficult, a bit more involved. So what you'll notice is that I have a trinomial in the numerator, I have a trinomial in the denominator, no greatest common factors to factor out. But even though this leading coefficient is not 1, I can still factor it. It's just I need to use factoring by grouping to do so. And so if you don't remember how to factor by grouping, I have a video for that, so I'll move this a bit quicker than usual. But how this works is you multiply the leading coefficient by this value here to get 18, and then you look for the factor pairs of 18 that will combine to a negative 11, and that's going to be negative 9 and negative 2. So what I'm going to do here is I'm going to replace the negative 11x with a negative 2x and a negative 9x. Okay, so again, I replaced this negative 11x with a minus 2x minus 9x. And again, how I did that was you multiply a and c together, that's the 2 and the 9, you get 18, and you think about the factor pairs of 18 that will add to, combine to negative 11, that's negative 2 and negative 9. Okay, and then I am going to recopy my denominator. We haven't factored that yet, but we will. Just worried about the numerator right now. And now we treat these in two separate groups. Okay, we look at the first two terms as one group. We look at the second two terms as a second group. All right. And from those two groups, we are going to look for GCFs. So I'm going to look at my first group right here, and I see that the GCF between these two terms is a 2x. So I'm going to factor out my 2x. And 2x times x will give me my 2x squared. And then my 2x times negative 1 will give me my negative 2x. Okay. And now from the second group here, I'm going to factor out a negative 9. Okay, and negative 9 times x will give me my negative 9x. And negative 9 times negative 1 will give me my positive 9. And you might be wondering why I decided to factor out a negative 9 instead of a positive 9. And the reason being is because I needed to get this sign to flip so that when I factored it, I get my negative 1 here, which will match the factor over here. So again, by factoring out a negative 9, I have to multiply that negative 9 by a negative value to get the positive, which is good because then these factors will match. So that is the fully factored numerator. And again, I have videos on grouping if you need to look at that a bit closer. And now I can go ahead. Well, I'm going to copy down my denominator again. We're not quite done with the numerator. Okay, and now what I can do in this numerator is factor out an x minus 1 from this group and this group. Okay, so I'm going to factor out x minus 1, and that's going to leave me with 2x minus 9. All right, and this is the factored form of this numerator here. And now I can go ahead and factor my denominator, which is just going to be a standard trinomial factor. And so I have x and x. And then since I have to multiply to a negative, I know I'm going to have one sign of each. And the factors of 2 that I'll combine to a positive 1, that's going to be a positive 2 and a minus 1. All right. So now I see that I have a common factor here of x minus 1 between the numerator and denominator that I can cancel. And that's going to leave me with 2x minus 9 all over x plus 2. Alright, with that said, guys, it's been demonstrated.